Thanks everyone for joining in person and in the metaverse. This is Observability for Earthly Applications, and my name is Danny. I'm a software engineer at Grafana Labs and a maintainer of the Grafana Loki project. And today I'm going to talk to you about how we're going to use monitoring and observability to look at what I'd like to call an earthly application to give applications that are not cloud native, running Kubernetes, microservices, service meshes. These services also need monitoring and observability like the very modern cloud native applications. And why do we do observability in the first place, right? It's because we care about reliability of our services. We could have the best service imaginable, but if it was only available half the time, nobody would want to use it. And so we use monitoring, and monitoring is not a new topic, right? It's been around forever, and this observability thing is this new idea that's come around of late. And so I'm going to try and define that term for you and then show you how that works in practice. So observability is really a property of a system. It's a property that indicates how you can get an insight into an application's internals through its external outputs, right? And so that can take the form of logs, it can take the form of metrics, it can take the form of traces. In the interest of time, we're not going to talk about traces today, and we're just going to focus on logs and metrics. So what are logs? And logs have been around forever, right? Since the very first applications, there have been logs. And these are just extremely simple ways for your application to say, hey, something is not right here. And it writes those to a file or a stream. And you can take that data and aggregate it centrally or just store it in a file and search it later. Metrics, on the other hand, are it's numerical data that you can analyze at a glance. So with logs, you have to query them and read them and try and understand what they mean and correlate them together, whereas metrics are numerical values that you can understand implicitly. So this is a car dashboard, and as we can see, there are various types of information here, all of which are numeric, and we can very quickly make sense of what these all mean. And when we talk about metrics, we have different types of metrics. We have counters, we have gauges. A counter is a value that keeps on going up, like your odometer. And we have a gauge, which goes up and down, like your speedometer. And there are other kinds of metrics that we can use too, but we're just going to focus on these two today. So who here is familiar with this website? By a single clap, so that the folks at home can hear it. Okay, all right, so most people. So what we're going to do today is we're going to look at a clone of this Hacker News application, which I very imaginatively am calling Slacker News, and we're going to add monitoring and observability to this application without changing a single line of code. So we're going to get full insight into how the application is working purely by looking at all of the data that already exists in the application. To do this, we're going to use a very modern stack, and these are some tools that I work on personally at Grafana Labs. First, we're going to look at Grafana, which is a general-purpose data visualization tool. Then we're going to look at Loki, which is a database built specifically for logs. And we're also going to look at Prometheus, which is a database built specifically for metrics. And by the way, Grafana can also support data from all these different other data sources. They can be software as a service applications, they can be other databases. You can really work with any kind of data in Grafana, and in fact we're also going to look a little bit at some MySQL data as well. Okay, so enough bullshit. Let's get to the demo. What I have here is a big old Docker Compose file. And this is defining the entire Slacker News application. So we're going to have the Slacker News service, which is based on an open source project called DataTowel. That is going to store its data in MySQL. And we're going to then pull in all of the logs from this application and indeed all of the containers into Loki and then work with Prometheus and create some alerts. And for the alert users, you will see this very conspicuous looking device down here that'll come into play just now. Let's hope it works. Okay. It's a smart light bulb, nothing too fun. Okay. So I'm going to start this up and pray that the demo gods are with me. Okay, cool. And so this is going to spin up all of the services in Docker Compose, and it's also going to run a script that's going to generate some sample users in this Slack and News application using a tool called K6. It uses a very simple JavaScript file, which I define to load a page, fill in a form, submit it. Very, very easy stuff. Okay, so this is Slack and News. Completely empty right now. We're going to fill it with a bunch of garbage. So we're going to log in as one of these test users. And let's just create a new post. So you'll see we're on this page here called /submit. So we're going to say, what's up, devconf. Okay, and there we go. So now we've got a single post in Slack and News. Again, nothing too exciting. I'm going to run another little script, which is going to place some random votes. So the script that I ran before set up 10 users, and this is going to place some votes. And so now you'll see as the script runs, let me zoom in a bit here. You'll see now we get more points. So this will be important for what comes next. Okay. So now we're going to have a look in Grafana and start looking at the logs that we've generated from these few actions in Slack and News thus far. And Loki, how many of you are familiar by the way of a single clap with Loki? Okay, so not too many. All right, cool. So Loki is, like I said, a database designed specifically for logs. And the idea with Loki is that you can just send it any old garbage, right? It doesn't care about the format. You don't have to agree with all of your teams about a schema for the logs and so on. You can just dump whatever you want, just streams of bytes. It's happy with that. And then the idea is that you label these logs with identifying information so that you can take the petabyte of logs that you ingested, filter them down to a set of logs that you're interested in at a particular time, and it's very important that we bring the element of time into this. And then we can query the data, extract certain fields from it, and so on. And this is going to, I'm really going to be blowing through these things very quickly, so I'll try to leave a lot of time for questions, and we can dive into the specifics later. So Loki has a query language called logql, and this is how we select all of the Slack and News logs. I've got a process that is pulling all of the logs out of Docker, sending them to Loki, and then labeling them with the container name, right? So we can see here container name Slack and News. That's what's showing up in this label. Okay, cool. So we can see all of the HTTP logs that have come through, and other logs, indeed, from this Slack and News application, which, by the way, it's just a Django application. So right now, if we wanted to have a similar experience without Loki, we would have to, SSH onto a server and just cat a log file, right? But what's the next thing you do? You run tail-f, right? So Grafana has that as well. So you can just click the live button. And let me zoom out a little bit here. And so now I'll place some more votes to artificially bump up my post here. And as we do that, you'll start to see some new log lines coming through, right? So this is pretty cool. But this is just showing us absolutely everything, right? Very hard for us to process right now. So let's do something else. I'm going to generate some more posts. So we're going to run that, and again, this is going to log in as those test users, create some posts, and just fill this database up. So you'll see a whole bunch of stuff coming through. I'm going to pause here. You'll see that it's logging in, but then it's also going to the submit page. Remember, like I showed you in the beginning? And it's doing a post, right? So let's only select those logs. So in Linux, or any Unix system, you would use a pipe, right, and then a grep, something like that. In LogQL, you still use a pipe with an equal sign for equality, and so we want to search for that. Now we unpause our live view, and now we can see these new posts coming in, right? So we can start to get a good sense of what's happening in our application. But again, like, we can take this another step further. So it's kind of hard for us to see like how many posts are actually being created per second now, right? We see that there's a bunch of data coming in, but it's not that useful for us yet. So let's exit live mode. And we'll see here in Grafana, it's already showing us a histogram of all of the logs that are coming through. And now we can replicate that by running what's called a metric query over our logs. So we can say, let's count. So this is not exactly giving us a per second value. Let's try and find a per second value. This is giving us every 3 seconds the number of lines that it's seeing. So we're going to do a count over time. And we're going to say, we're going to give it a time range of 1 second. So it's going to go back in time over the time range, which right now we have set to an hour. We're going to filter that down to 5 minutes. And it's going to go back in 1 second chunks, and it's going to count all of the log lines that match this query. And now you can see we have a per second indication of how many of those posts were getting submitted to our server. So great, so now we have an idea of how many posts are being created on a per second basis. But we've just been exploring the data here. This isn't in a format that we can share with a colleague or be useful in the long term. So let's create a dashboard out of this. So we're going to come here to the plus sign, create dashboard. I'm going to add an empty panel. And we're going to run that same query, filter down to 5 minutes. And let's just say here, posts over time. I've done this before. Okay, cool. And now we can save this dashboard, call it Slacker News, and share that with whoever on our team we want to share this with. And of course, if we set this to auto refresh and we create some more posts, as that happens, we'll start to see some more data coming in, and I can take a sip of water. Okay, things are starting to happen. Oops. Okay, great. Now, we're looking at the data from the perspective of the logs, right? But of course, these posts are going into a database. So why don't we look at it from the database's perspective as well? So if we go back to this Explorer view, I've got my Grafana configured to communicate with the MySQL server, also running in Docker. So let's format this as a table, and so now we can say select star from app post, which is a table in the database. And now we can see all of the posts that have come through, and I should say that all of these are randomly generated, so don't blame me if there's anything particularly weird or rude or offensive. Okay, cool. Tote bag, narwhal, Stumptown, raw denim, sounds legit. Okay. So now let's do a count over all of these posts, and let's just alias that as value. Cool. So we've got 327 posts right now. We take that query, we come over here into Grafana, add a panel, and zoom out a little bit here. We're actively working on making this process a little bit simpler, so you can just add directly to a panel in a dashboard. So this is one extra step right now. Okay, cool. And now it's not giving us any data because the data doesn't have a time field. So Grafana is fundamentally a time series visualization tool. However, because this is a static value and there's no time field associated to it, we can still represent that data. And we're going to use the stat panel. So that's going to interpret the data as a single value instead of a value over time. So we have 327 posts, which is what we saw. And let's edit this and just say posts count. Grand. So now how can we unify the view in the database and the view in the logs, right? In other words, how can we correlate the number of posts that existed in our database over time with the HTTP requests that were coming in, right? And we need a metric for this. And we need a metric to come out of the database and be associated with particular time intervals. Now, we could go into the application and we could modify it so that it could export these metrics. However, the rule for today is no touching the code, right? So what we can do is we can use a tool called an exporter. And what an exporter is it's a piece of software that runs alongside another piece of software. And it queries that service that's running and exports metrics for it in a format that Prometheus can understand. And so what I've got set up here is a SQL exporter. And if we look at the config for this, we can see, let's just look at this one for now. We can see that it knows how to connect to the database. And we've got a number of collectors here. So here's that query that we just ran in our database, yeah? And now we want to turn that into a metric, and you'll see why that's valuable in a second. And that metric name is posts. So let's come back to Explore, choose the Prometheus data source this time, and go posts. And now you can start to see the number of posts as they were increasing over time because of those requests that we were sending through. Okay? So again, we can take this, add it to our dashboard, and now what you'll see when we put these one under each other, and let's just say posts over time here again, you'll start to see an increase in the number of entries in the database around the time that the logs were showing more requests, right? So nothing too surprising there. However, there might be information that we can't derive from the logs, that we can only derive from the database. So for example, we can also have the post per user. And in the logs, we don't have the user association to the post that's creating it. We just have that log line that just says post to submit, right? We're not logging the other details there. But we do have that information in the database. And we have a query like this. Now the difference here is that we're not just getting a single value. We need to get a value that's indexed by a label. And in this case, the label is a user ID. So we want to have a metric per user ID in this case. So let's have a look at what this metric looks like. Posts per user. So now you can see that we also had this increase. Let's widen this to 15 minutes here. And you'll see that user ID 4 at this point in time had 24 posts, user ID 5 at 23, and so on. And this is when things start to get interesting. We can now start doing aggregations over this data as well. So we can say, well, what is the increase on a per minute basis of these posts per user? So we can start to see that user 4 is posting quite an abnormal number of posts per minute in that instance, and then user ID 10 was doing the same over here. And we can do the same for votes. We can see which user is casting more votes than another. And so what we're going to do now is we're going to take a metric and then build an alert based on that metric. Let's have a look at that metric quickly, votes by user. So right now we don't have any really. So we're going to generate some votes, just a small number of votes. And let's have that refresh every few seconds here. Let's look at it without the increase first. Okay, so now you can see things starting to spike. So we'll put back that metric query now. And if this query syntax looks a bit wild, it's it's a bit different to SQL and so on, it's really easy to get the hang of, and there's lots of cool like statistical functions that you can use. Right, so now we can see that one particular user here is posting more than the others. So let's put a rule in place that says if one user votes more than 10 times in a minute, then we're going to send an alert, which should hopefully turn on this light bulb. And this is another feature of Prometheus. You can configure alert rules which run a metric query, right? And if it returns a value, then it will send an alert onto a system called Alert Manager. And I've got Alert Manager configured to send a webhook to a service that should hopefully turn on this fucking thing. All right, cool. So now, before, we were just using 5 virtual users here in case 6. So let's ramp this up to, say, 30, and we'll do this over a period of 30 seconds. And we'll watch this in real time as well. And if the light does turn on, please go, ooh, ah. Okay, so we can see things starting to happen. Which user is it going to be? In retrospect, I probably should have set the threshold lower so it wasn't this big awkward silence. But anyway, okay, here we go. There we go. Ooh, ah. Okay, thank you for your tolerating my nonsense. All right, great. The astute viewers would have also noticed that there's another alert called MySQL app. But where is this metric coming from? We haven't defined that anywhere. So before we used a SQL exporter to run a query against a SQL database, take that response, turn it into a metric. But what we can also do is just have an exporter that knows about all of the MySQL D tunables and also expose metrics for that. And in fact, I've got that set up, and there's a pre-built dashboard for this, which I just downloaded off the Grafana website. And now you can see all manner of interesting metrics about the MySQL server. And this exporter also, okay, so those users are still going off again. And this exporter that provides all the metrics that are showing up in this dashboard also provides a metric called MySQL app. And as you can see, it's equal to 1 because MySQL has been up. But now, if we go ahead and kill it, whoops, DB. We should hopefully see that go red. Okay, cool. And we'll bring it back up here again. Segfault, that's always a great message to see in a demo. Okay, great. What else is there to show here? Okay, there's a whole number of exporters and integrations that are available for Prometheus. So if any of you are running any of these services, or databases, or pieces of hardware, you can get metrics for these things today. And most of these come with dashboards that make use of these metrics. Another one that's pretty interesting is the node exporter. And the node exporter will export metrics for your underlying host, so you can get memory, disk, CPU utilization, and it comes with a predefined dashboard. And Grafana makes this really easy. If you find one on the Grafana website, you can just copy this ID and then come on here into Grafana and just go import, paste the ID, choose your Prometheus data source, boom. Pretty easy, right? And now, of course, because we have all of this data, we could create an alert for like if our CPU utilization was above a certain threshold for the last 30 minutes, say, and you needed to alert someone to trigger a scaling in your Proxmox or whatever you happen to be running. All of these tools work in the Kubernetes cloud native space very well, of course, and for my own work at Grafana Labs, where we run the hosted Loki product, we're busy looking right now into auto-scaling our queriers, which is effectively the part that handles all the queries coming in. We're looking at auto-scaling those up and down based on their utilization. And you can do this all because of metrics. So yeah, I think that's pretty much everything I wanted to cover. So I'll stop there and take any questions and have a cough, because I've been waiting for one for a while. All right. Any questions? Let me have a look in Slack while you guys think of something.
Just a quick question on this side.
Yeah.
Do you use like the lights as like a visual thing in real world, or is this just for the demo?
Thank you. Yeah, that's a good question. No. It was supposed to just be a cute little thing for the demo, but in reality, you would connect Alert Manager to something like OpsGenie or PagerDuty or a klaxon in your office or whatever you want to alert you to the fact that something is wrong and needs to be looked at. Yeah, or to Slack. You can get it to send really nicely formatted messages to Slack as well. Okay, let's see if we have any questions from the metaverse. I should really stop saying that.
I've got one as well.
Yeah.
So with Loki and all the logs that you ingest, you say that they can be in any format, any kind of schema.
Yes.
How do you set the rules for parsing those? And like extracting things like the time and maybe like for certain logs, the HTTP response code, that kind of stuff?
Great question. So we have a tool called Promptail, and Promptail is the piece that will scrape the logs from disk or from Docker, pre-process them a little bit and send them on. But the processing that you do on your logs can happen in two places, right? It can either happen on the client, like I'm doing here, where I connect to the Docker socket, figure out where all the log files are, and then grab a meta label and turn that into that container label that you saw there. But if you wanted to read a file and, for example, parse the log line and pull out a timestamp from that, you could do that. Or pull out a single piece of information from that log and use it as a label. I'll show you a quick thing here. So if I go back to the logs for that Slack and News container, let's pick one line here. So let's look at this last parameter here, right, which is, I think, the content length of the response. Yeah, so let's filter for just this. Okay, so we just get all of those. And now, you see we've got some that are like 36 bytes, some that are 37 bytes. So what we can do is we could use regex if you wanted to. But I'm going to use another parser here, which is called the pattern parser, which is quite fun. And the syntax you can learn about, but right now we're just going to say content length, okay? And what that's going to do is it's going to give us a label here for each log line that's extracted that value out. So we don't need to define up front what the log format is going to be. We can do this at runtime. And then we could also aggregate over this. So we could say, let's do a count over time. And there are more functions than count over time, but this one is the one that's easy to represent. So we'll do that per second. But now, on top of that, we're going to wrap this in a sum by content length, which is that label that we extracted at query time. And now you'll see that we've got two streams. We've got content length 36 and content length 37. And if I just zoom in on this, we can see that there's only a couple that have content length of 37. So, you know, in another example, you would look for all the HTTP 500s, you know, and then plot those over time, for example. Does that answer your question?
It does. Awesome. Thank
Great.
you.
Okay. Let's see here, track 4. Not seeing anything here. Or maybe it's not updating. Any other questions while we wait? Going once, going twice. All right, thanks for your time.